Hello, everybody. My name is Mario Aquino. I'm one of the organizers for the Strange Loop Conference. I'm joined today by Ambrose Bonnaire-Sergeant, who is a past speaker at Strange Loop. And we're going to be doing a little bit of catching up. But before I get to Ambrose, I want to mention that Strange Loop is going to be held, hopefully, this year, pandemic willing. The dates that we have the conference scheduled for is going to be October 1st and 2nd, 2021, with a pre-conference day happening the day before the first day of the conference on September 30th. The entire conference this year, unlike years past, is going to be held at the St. Louis Union Station Hotel, which has actually gotten a lot of updates since the last time we ran the conference, and so it should have a lot of really fun things for folks who are coming in from out of town to explore and enjoy. Also, given that we've got this global pandemic, we will be working with local public health officials to make sure that the guidelines and safety precautions that we take for the conference will allow everybody to have a safe stay while they're in town visiting us and hopefully really enjoying themselves at the conference. If you want to find out more information, you can visit thestrangeloop.com. So with all that out of the way, Ambrose, thank you very much for joining me on this Zoom. So as I mentioned, you spoke at Strange Loop twice already, the first time in 2014, and you gave a talk on typed clojure, and then the second time the next year in 2015, again on
Again.
type clojure, and your talk was titled From Optional to Gradual Typing. So that was 6 years ago now, and I know a lot has happened since then. So I wanted to catch up with you. So I don't want to, like, a lot has happened, both in typed clojure and for you. And
Yeah.
I wanted to give you a chance to talk about it a little bit.
Yeah. Thanks for having me here, Mario. But yeah, you've given me a little, you gave me a little homework trying to think about my Strange Loop experiences. And I realized that I think I pretty much, since I came to the States in 2014 for my PhD, I've been able to attend every year. And it's sort of become a family affair because I started bringing my wife 3 or 4 years ago, and we have our own, you know, we still talk about Strange Loop talks. Like I was asking my wife, like, what was our favorite Strange Loop talk? And there was one by, I forgot her name, maybe it's Emily, but it was about voice coding with software called Talon. And me and my wife both ended up using it, and we
Right on.
would never have seen it. Yeah, and I still use it every now and again. It's, you just have to learn an alphabet and you can just vim with your mouth. And yeah, if you check it out on YouTube, there's, I think the catchphrase was whale quench, which is the whale is W, quench is Q. So that's how you get out of vim, whale quench. And yeah, it
Awesome.
was, yeah, it was epic. But yeah, so yeah, 6 years, that's nuts. Yeah, so I guess back then, I just started my PhD, and I remember starting my first Strange Loop talk. I had my advisor in the audience, and then my advisor's advisor next to him with his arms crossed, like leaning back. It was terrifying. But like the room was like packed. It was, yeah, a very memorable experience. That was awesome. And yeah, the next year, um, I so that first talk was basically like, what is type closure? And then the next year, I was looking for research areas, and this gradual typing idea popped up, and I ended up doing a crowdfunding campaign for it. And then this Strange Loop talk was sort of a result of that. And that's been an interesting sort of line of work for me to reminisce on, because it ended up facing a lot of implementation issues that effectively made it impossible to implement in sort of, it's hard to explain exactly what the problem was. this is something that works really well in Racket, where you have the entire VM, you control everything basically.
Mm-hmm.
But this particular idea doesn't work that well in hosted languages. And effectively the idea is this, that if you have an untyped language and you write a type system for it, at some point there's going to be communication. Well, how do you make sure the invariants of the type system aren't violated? And basically, this idea of gradual typing proposes a solution. And it turns out, because of the way that Clojure is implemented very close to Java, in the sense it's a light wrapper, you end up with these crippling problems with final classes, because you need to wrap things and you can't proxy a final class. Anyway, it ended up boiling down to something like really annoying and boring like that. But since then, Rich Hickey released Spec and has given me a lot to think about what's the relationship between generative testing and static type systems. And that is something that I've been working on over the years. At first, when I saw Spec, I recoiled at this particular design decision. If you're familiar with Spec, you should check out what fspecs does when you try and conform it. But basically,
so let me just say that so for the folks who may be watching this interview, they may not be familiar either very familiar with Clojure or very familiar with Spec. So could you mention a little bit what Spec is and how it helps describe types in Clojure?
Yeah, well, so Clojure itself is a Lisp that runs on the Java virtual machine. It compiles to Java bytecode on the fly. And Clojure is an untyped language. So the community has been thinking about ways to verify programs. And there are two main ways at the moment. One is static typing and the other is runtime verification. And runtime verification, you can have several approaches. One, I don't know, perhaps one of the most innovative approaches I've seen in this area was this library called clojure.spec that Rich Hickey designed. And it's sort of, it takes ideas from all sorts of things, from Racket to RDF and generative testing, quick check, that sort of things, and wraps it up in this coherent package that has left me thinking for a long time about why isn't this normal?
When you say normally, why isn't it more widely embraced? How do you mean?
I mean, let's step back from the Clojure community for a second. But why haven't I seen something like this before? And I ended up asking Rich a few questions about why does that look like a contract system, but it's not a contract system? And sort of, Rich had a very specific design in mind it's extremely pragmatic. And he rejects this notion of having to wrap values at runtime, because it's quite a performance suck. And effectively, if you start wrapping things in a dynamically typed language, some of the benefits of using the language are negated, because things get checked all the time. And this is an open research area, basically. And Spec is a really cool, it's really quite difficult to define exactly what Spec is, but the basic idea is that you can summarize what you expect a program to do in a specification, and Spec has different ways of utilizing that specification to destructure data, to conform it, to check whether a program actually has that specification. And of course, if you just want to read the spec and communicate with other people, And I guess to segue into my own work, one thing that Spec does not do is attempt to do any static checking. And recently I've been playing around with Spec to see can I add something more static typey, something that looks like a static type to spec? And if you think of like, if any of the viewers are into functional programming, like the identity function, the map function, the filter function, if you look at any of the type signatures of these things in like Haskell or Java or anything like that, you'll see that there's polymorphism that's like for all A, B. And this is stuff that I haven't really seen a good answer to verify at runtime. So here's the question is, you have one of these types. How can you verify using generative testing that it actually has that type? And I mean, I guess, how can you best verify it? Because it's impossible to test for all inputs, basically. But that's sort of the area that my second strange loop talk has sort of segued into, which is I have the type for map, and if I was in the gradual typing sense of things, I would be like, well, let's wrap map and make sure that any values that come in conform to that, and any values that come out conform to this, and then this would, I guess it would be pushed into production as well. It's just like a whole can of worms, effectively. But if you, this idea I've been having is, well, let's just step back for a bit. How could we simulate checking the static type like as a black box, effectively? So for example, the identity function, for all X, takes an X, returns an X. How would we do that? How would we, if I just gave you an object and said, is this the identity function? What would you do? And I said, is this of this type? And effectively what I've been working with in spec is a way to enumerate a bunch of useful subtypes of this type. So what this identity function really means is it says, if you give me an integer, I will return an integer. If you give me 1, I will return 1. If you give me nil, I'll return nil. If you know, give me any, I'll return any. So that's the basic approach I've been working with the generative testing of functions. Yeah, so that's the stuff that my second strange loop has sort of evolved into 6 years later, which is very strange. I don't know if my advisor would approve.
Well, so you more recently published a library to add spec support in typed clojure.
Yeah.
So can you talk a little bit about that? And is that work effectively as complete as you want it to be? Can you talk about how you have used it and what sort of feedback you've gotten from folks that are trying to use it, that are themselves working with typed clojure?
Yeah, so I would say type clojure is definitely in the design phase at this point. So for context, I finished my PhD July of 2019, and I had basically open problems that explained why people have migrated away from type clojure. And one of them was the runtime support, like some sort of spec integration. But yeah, so the example with the identity function was sort of the flavor of what I was going for in this spec extension. So the idea would be that you write a spec or a type or basically something that can be both a spec and a type. I'm not really sure if, well, I'll put it another way. I extended clojure spec to be able to write static types as specs, or write specs that look like static types. So the type for like identity and map and filter and all that stuff, you can write them in spec. And this is basically a big experiment right now. I don't think anyone should be using it for anything. I'm almost certain no one is. But the dream is that you can write so this particular, the thing I'm most excited about is when you're dealing with the boundaries between typed and untyped code, is often around these little utility functions like an assoc wrapper, like I'll translate that to, but basically functional programming is about putting building blocks together and building towers of useful helpers and abstractions and stuff like that. And you end up with a bunch of different functions and units of program that that you need to specify and then type check. And then if you sort of like recursively think that through, it's like, well, quickly you're going to have to specify everything. Oh God, we can't do that. So this stuff with the spec, this experimentation I'm doing with spec is one answer to that question, which is like, how far down do you actually do the static type checking? You effectively need to tell the type system what you expect, what they should expect at the other side of the boundary. But the hope is that spec would be the thing that you trust, that has actually verified that that information, that specification is accurate. And yeah.
You allude to that a little bit in your 2014 talk, which I happened to rewatch recently, in which you advocated for either adopting a third-party library or adding type specifications to your own library because of the sort of necessity to give as much information as far as you can in typed clojure code bases that you may be working in. That boundary that you describe, that is the thing that you want to try to provide as much exposure to make that boundary separating you from in the typed world from as little as possible outside of that world to increase the chances that the type checker is going to notice things where types don't line up based on what your expectations are.
Yeah, I probably said something like, I don't have millions of dollars and I don't have TypeScript behind me. I don't have Microsoft behind me. Well, I've certainly said that, a sassy remark like that. But that, if you look at the TypeScript world, they have managed to have these large repositories of shared type annotations, so the whole community can share the burden of the, I call this the annotation burden, because it's truly, it's an immense task to take an untyped language and then suddenly have a static type system that has all these very precise rules, and you can't fudge anything. You have to think every single step. So yeah, and it's a community effort that hasn't really panned out in type clojure, but I'm not really sure what's going to happen with static typing and clojure in the future. There's like, I feel like I started off in maybe 2012 with type clojure, thinking I'm going to make the most airtight, no compromises type system, you know, sort of coming from the high and mighty.
The ivory tower.
You know, yeah, the ivory tower, exactly. I was doing my undergrad thesis with Rowan Davies, who has done a similar thing for standard ML. Believe it or not, he took standard ML and then put a layer of types over that. You know, standard ML already has types. So it was sort of the perfect advisor to to make, you know, to keep me up in the ivory tower.
Well, right on. Why don't we leave it there? Ambrose, I want to thank you very much for making time to talk with me today. And I'll just say once again that we are hopefully presuming that things continue to go in a positive direction with regard to vaccine distribution. We are hoping to be able to have an in-person Strangeloop conference this year, 2021. That again will be October 1st and 2nd this year. And we hope to see you there. Ambrose, once again, thanks so much for your time.
Thanks, Mara.